Hello, everyone. Today we will explore Chapter 1, the definition, features, and deployment forms of blockchain. First, let's understand why blockchain is necessary, or rather, the background behind its emergence. In today's rapidly developing internet age, the web is filled with false information. For example, where does the chicken in braised chicken rice come from? Some reports indicate that it comes from unlicensed workshops. Additionally, counterfeit products and false information online have led to serious credit issues. Therefore, solving these issues has become a pressing technical challenge that we need to address. Now, let's explore the history of blockchain. As early as 2008, Satoshi Nakamoto first introduced blockchain in his paper Bitcoin, peer-to-peer electronic cash system. Hence, blockchain was described as a ledger for recording Bitcoin transactions. In 2015, The Economist magazine referred to blockchain as a trust machine. In 2016, China officially defined blockchain in the white paper on China's blockchain technology and application development. In a narrow sense, blockchain is a chain-like data structure that connects data blocks sequentially in chronological order, ensuring the tamper resistance and forgery resistance of the distributed ledger through cryptographic methods. In a broad sense, blockchain is a new distributed infrastructure and computational model that uses a blockchain data structure to validate and store data, employs consensus algorithms by distributed nodes to generate and update data, ensures data transmission and access security through cryptographic methods, and utilizes smart contracts composed of automated script codes to program and operate data. So, we can summarize blockchain as essentially a distributed shared ledger, characterized by a blockchain structure that is maintained by network nodes. Through the effective combination of distributed ledger technology, cryptography, consensus algorithms, and smart contracts, it ensures four key characteristics of data without relying on third-party intermediaries for credit endorsement: resistance to tampering, forgery prevention, traceability, and auditability. Now, let's compare blockchain with traditional internet. Traditional internet transmits information such as text, images, and videos. In contrast, blockchain transmits assets such as money, contracts, and patents. Therefore, blockchain represents a major shift from the Internet of Information to the Internet of Value. Next, let's compare blockchain with distributed ledgers. How do we differentiate between blockchain and a distributed ledger? It depends on how many copies of the ledger exist. If there's only one copy, such as with a bank account, then it's straightforward. But if there are multiple copies, then the question arises: who has the right to use these copies? For example, if a bank account is shared by the entire family, with your parents, siblings, and others having access, then the question is, who has the right to use it? This would require a permissioned private ledger. More broadly, if anyone can possess a copy of the ledger, who will maintain its integrity? There are two potential approaches. One, a trusted ledger owner or agent who is responsible for maintaining the ledger's integrity. For example, you may authorize a friend to manage your account. Two, the fundamental idea of blockchain is to allow anyone to share the ledger without needing mutual trust. This is one of the major features of blockchain. Therefore, blockchain is a forgery-proof, tamper-resistant, and traceable blockchain data structure built through transparent and trustworthy rules in a peer-to-peer network. Distributed ledger technology, on the other hand, is a collection of technologies that enable distributed ledgers. Thus, we can conclude that blockchain is a technical method for achieving distributed ledgers. In other words, blockchain is a subset of distributed ledger technology. From a blockchain architecture perspective, we can divide it into four layers: the user interface layer, the distributed virtual machine layer, the consensus layer, and the data network layer. Structurally, blockchain technology is a distributed system. We know that networks generally have three configurations: centralized, star-shaped, and distributed. Blockchain is based on a distributed configuration. Blockchain nodes supervise each other and perform real-time reconciliation, which avoids the possibility of fraud by centralized accountants and enhances data security. However, this fully decentralized blockchain structure also has some drawbacks, such as being unable to meet the demands for storage space, network bandwidth, and scalability in larger systems. Let's now explore other technical features of blockchain. 1. Disintermediated trust establishment. This means that, in situations of information asymmetry, two parties in a transaction can automatically establish trust without requiring the credit endorsement of a third-party institution. This is one of the primary features and functions of blockchain. 2. Transparency. All nodes in the blockchain can query block records, and every transaction is broadcasted in a way that makes it visible to all blockchain nodes. 3. Temporality and tamper resistance. Blockchain has strong temporal characteristics. By using timestamps, blockchain ensures strong traceability and verifiability, which guarantee that block data is tamper-resistant. 4. High reliability. The abnormal behavior or malicious actions of some nodes do not affect the availability of the service or the integrity of the data. Next, let's discuss the deployment forms of blockchain. There are three types of blockchain deployment: public blockchain, consortium blockchain, and private blockchain. A public blockchain means that any user with an internet-connected computer anywhere in the world can join or leave the network at any time. The most typical example is Bitcoin, which uses consensus algorithms like POW and POS. A consortium blockchain is a multi-centralized blockchain with an access mechanism maintained by a group of organizations or stakeholders. Consensus algorithms used in consortium blockchains include PBFD and Raft. A private blockchain is limited to a specific organization or enterprise, where read access is restricted and not publicly available. Finally, let's summarize the differences between these three deployment forms. In terms of participants, anyone can access a public blockchain, whereas consortium and private blockchains have an access mechanism. Based on the degree of centralization, the public blockchain exhibits the highest degree of decentralization, while the consortium blockchain follows a multi-centralized structure, and the private blockchain is centralized. As for consensus mechanism, the public blockchain uses POW and POS. The consortium blockchain uses PBFD and Raft, while the private blockchain uses authoritative accounting. For transaction efficiency, due to the large number of participants in the public blockchain, its transaction efficiency is the lowest. On the other hand, consortium and private blockchains, with their controlled access mechanisms, have higher transaction efficiency. When it comes to incentive mechanism, the public blockchain requires an incentive mechanism, while consortium and private blockchains may not, as they are more focused on internal operations of organizations, such as governments and businesses. That wraps up our discussion for today. This lecture ends here. Thank you, everyone.